Okay, we're in Chapter 2, Section 3 of Barnett. This is Quadratic Functions. And we have several goals for this section. For now, we'll identify and define quadratic functions, equations, and inequalities. So recall that if a, b, and c are real numbers, and a is not equal to 0, then the function f of x equals ax squared plus bx plus c is what we call a quadratic function. Its graph also has a specific name. It's called a parabola, as you might remember from looking at the graph of x squared in the previous section. And quadratic functions are examples of polynomial functions, which we'll get into later in the chapter. So remember that for that. This is called the general form of a quadratic function, as it's written here, ax squared plus bx plus c. And you might remember that another way to write a quadratic equation is in what's called vertex form. This vertex form identifies the vertex, namely the point with coordinates h, comma, k, and the vertex is the peak of our parabola, right? So if we have a parabola, this would be the vertex. If it's upside down, it's this peak here. That's the vertex. And that's why it's convenient to sometimes use with the vertex form. A lot of the applications in this class are going to ask us to find the vertex of a parabola. Remember, the revenue and profit functions are illustrated via quadratic functions, so their graphs are parabolas. So when we're looking for maximum profit or maximum revenue, we'll oftentimes be looking for the maximum point of a parabola, in other words, the vertex. That's why it's convenient to convert general form into vertex form sometimes. Well, how do you do that? You do that using completing the square. That's a process you saw in Math 125 at Pierce College or Algebra 2 anywhere else. So there is a video I'm going to post that you guys should look at to remember how to complete the square. Let's do it for this example here. This example illustrates the procedure of how to convert general form into vertex form of a quadratic function. So we complete the square of this function, on this function, negative 3x squared plus 6x minus 1, to find the vertex. The very first step you should take is to factor the coefficient of x squared, that negative 3, out for the first two terms, the quadratic term and the linear term. So when I factor out a negative 3, I'm left with x squared minus 2x, and outside the parentheses I still have the constant term, the minus 1. Okay. The next step is to add 1 to complete the square inside the parentheses. Really quick, when you have x squared minus 2x and you're trying to complete the square, you take half of this number and you square it. Half of negative 2 is negative 1, squared is positive 1. So that's when you add to complete the square. Again, there's going to be a video posted on completing the square. If you don't remember how to do this, it's explained there in more detail. But because we're adding this positive 1 inside the parentheses are being multiplied by negative 3. So really, if I were to distribute back this negative 3, I would be adding a negative 3 to my equation overall. So if you remember, one problem with completing the square is you have to balance your equation when you do that. So we have actually added a negative 3 here. So we must add a positive 3 to the outside in order to balance our equation. So what our equation looks like now is negative 3 times x minus 1 squared plus 2. And that is in vertex form. Okay, that right away tells us what the vertex is. The vertex is formed by h and k. In this case, h is 1 and k is 2. I'm going to rewrite the formula here to remind you why that is the case. Notice our formula has x minus h in it. So when we match up with our answer here, we have x minus 1 inside the parentheses. H is actually equal to 1. The formula itself has a negative sign, a minus. So when you match them up, h is 1, k is positive 2, because this is a plus k. So that's the vertex, 1, comma 2. The quadratic function opens down, since the coefficient of the x squared term, the a, is negative 3, which is negative, right? So if you have a negative a, the parabola opens down. And a is, once again, the coefficient of the quadratic term. Okay, let's talk a little bit about the intercepts of a quadratic function. How do you find those? Well, let's find the x and y intercepts. It says of f of x equals negative 3x squared plus 6x minus 1. to find the x-intercepts first. What do? Well, the x-intercepts, you might remember, are called zeros or roots or solutions to the equation, right? So what you do is you set f of x, or your y, equal to 0, and you solve for x. So set y equal to 0 and solve for x. And there are several ways you learned before how to solve a quadratic equation. When one of the sides is equal to 0, that's factoring, completing the square, quadratic formula, whatever it is you want. Over here I did the quadratic formula for you, which I reminded you of. Right, so this is all old stuff. You could pause the video if you'd like to see what's plugged in, but a is -3, b is 6, and c is -1. Okay, and that's how we obtain those two answers for the x-intercepts. Okay, well, how do you find the y-intercept? If you let x equal to 0 and solve for y, then you'll be able to find the y-intercept. So set x equal to 0 and see what is y. Well, setting x equal to 0 gives me -1, as you can see here, right? If I set x equal to 0, I just get this line, and every term dies off because every term has an x except the constant. So the constant term -1 is my y-intercept. 0, -1 is the y-intercept. Okay, and finally, to generalize, for f of x equals a times x minus h squared plus k, if a is different than 0, then the graph is a parabola. If a is bigger than 0, the graph opens up. If a is less than 0, the graph opens down. The vertex is always h comma k. The axis of symmetry is always the x-coordinate of the vertex, namely the vertical line x equals to h. So remember, if you have a parabola, like this one here, the axis of symmetry is the line that literally splits the parabola into two mirror images, two halves. Goes through the vertex, and since the vertex is h comma k, that's why the line of symmetry is x equals to h. F of h equals to k is the minimum if a is positive, otherwise the maximum. The domain, of course, is the set of all real numbers. The range is all the set of real numbers y, such that y is always less than or equal to our y-intercept k if a is less than 0. And if a is bigger than 0, then the range is y. The range is all the real numbers y, such that y is less than or equal to the y-coordinate of the vertex k. That's as long as a is less than 0. Or, if a is bigger than 0, the range is simply all the values of y that are bigger than or equal to the y-coordinate of the vertex, right? All we're saying here is the range is simply everything above the vertex if the parabola opens up, or the range is everything below the vertex if the parabola opens down.